Oh crap. Okay. Well, the phone rang. For some reason when the phone rings, it interrupts the YouTube video, and I don't know how else to fix that. So let's pick up. Arithmetic is adding. If you're geometric, it means you're multiplying. So let's look. Remember, to do arithmetic, I told you it's the D, and always take second minus first. If it's consistent, great, it's arithmetic. Or you take your second and you divide it by the first. Hopefully you guys will realize this is not geometric, and what's happening here is we're constantly subtracting 7, right? If you're like, I don't get it. Well, look, negative 11 minus negative 4, negative 7, and then just keep going. So this is arithmetic, which I'm just going to jot here. It does matter. Okay. So doing the arithmetic, great. Now you have negative 4 as the first term. Then our rule is we take the term. If you remember, recursive uses the term right before it. Just always set it up like this. So the way we write the term before it, if you recall, is just n minus 1. So think, if I want this term, because the first term is done, so I'm on the second term. How can I get this second term? By using the term prior. Well, if I take the term prior, all I need to do is do what to get to this term? Subtract 7, which is the common difference. This is your recursive formula. Now I will tell you the most common mistake people make is we forget the initial condition. If you forget the initial condition, you can say you got half credit. You cannot give me just this formula. This should make sense. If you give me this, I'm going to say, well, n minus 1 is the term before it. What the heck is the term before it? So you need that. All right, well, let's go over now what the explicit looks like so you guys can clearly see the difference. Explicit should be pretty simple. Explicit, here we go. We start with a sub n equals, again, it's arithmetic, the first term, not writing the formula because you should know it, plus common difference, and then n minus 1. And then I really want you guys to simplify it, and you guys get 3 minus 7n. Again, explicit, you can find me any number you want. Recursive, you constantly need the terms prior. Sometimes you can write an explicit and a recursive on your sequence. Sometimes you cannot, and sometimes it can only be recursive, and I will eventually show you that. All right, let's take a look at another example. Same thing. We're going to do a few of these, and then I'll show you the quote-unquote special situation that you only can do recursive. Okay, so here's our next one. You guys have, so this was, we could here. So this is A, we're on B. All right, 3, 13, 23, 33. So let's do the same thing we just did. Let's do recursive. All right, well, starting recursive right away, I know my first term is 3. All right, first we want to figure out arithmetic or geometric. Well, think about this logically. Nothing I can multiply will get me there. But how can you get from each term to the next? Add 10. Great job. So that's your common difference. So you guys know, let's mark this down. It's arithmetic. Then here we go. Your rule. A sub n equals, remember, always take the term before it, which is little n minus 1. How are you getting this? I should say you're on the second term. At the second term, what are you doing to the first term? You are constantly adding 10. Plus 10, this is what you guys would give if I asked you for your recursive. Okay? And you guys hopefully can see something, which I'll show you in a moment. Your explicit. A of n, here we go. First term, common difference, n minus 1. You guys simplify, remember, distribute, combine like terms. You will get negative 7 plus 10n. And here is your explicit rule. Hopefully you guys can compare the difference. Again, recursive, you need the initial. So think for the recursive, you need at least 2 things. You need the initial, you have to have 2 things. The initial, the rule, the initial, the rule. Explicit's just the rule. And I mean, look, you constantly are working with the common difference. It's kind of along the same nature. All right, let me show you one more of these before I show you the special ones, and then you guys are done. All right, let me do a C. Okay, so here are your numbers for C. 2, -4, 8, -16. Okay, I'm going to write this while maybe some of you guys are staring at that. Recursive, explicit. All right, so let's look. Are you adding? Like, you have to kind of observe. Hopefully, you guys should realize you're not adding the same amount each time. But what's happening is you are multiplying. 2 to get to -4 is -2. Let's see, is that the same for everybody? -4 times -2, 8, check and check. Again, you could take a of 2, -4 divided by 2, and you get -2. So this is a geometric. Here's how we do geometric. Same thing, a of 1 equals 2. A of n equals, well, let's write, you take the term before it. So if you guys already have this and you want this term, we're taking this term and you're just multiplying it by -2. So you guys can just put the -2 in front, and there you guys go. You want to put the -2 behind, you can. You have to make this a subscript. n-1 must be a subscript. And then here is your explicit. Remember, it's geometric. First term, common ratio, and then n-1. First term, explicit for the geometric is very easy. So hopefully that makes somewhat of sense for you guys. Then I'm going to show you these two situations that are the special ones that only recursive rule can happen. Again, for this, you could do recursive or explicit. Here is what we call the special situations where only recursive can happen. These are definitely a lot more tricky. Just try to at least pay attention. Hopefully you can understand. All right, so I want us to write recursive rule because there's no way to write explicit. We're almost done. 2 more problems. So this is, we could say, question number 3. So 3 types from today. Okay. So the reason why this is what we call a special rule is because it's not like we can do recursive and explicit. There is no common number that takes us from here to here, here to here, here to here, whether we multiply it or we are dividing it. There is no common difference. So the only way for me to really do this is to kind of just tell you what it is. What we have to do with the special one is you have to use more than one term. You can use more than one term. If you guys recall, when I did this with you, I took 2, oops, not that one. For this one, I took 2 terms and I did the work, right? Like we did 1 minus 4 is -3. 4 minus -3 is 7. Same thing kind of with this one. 2 times 3 is 6. 6 times 3 is 18. So what we're doing is we're using terms, a couple of terms before it. So hopefully maybe you guys see a pattern. And if not, here it is. Question, what's 1 plus 1? 2. What's 1 plus 2? 3. 2 plus 3. 5. 3 plus 5, 8. So sometimes you want to think of it in like your head of how it's done. And what's happening is we're taking the 2 terms prior, adding them, and that's how we get the third. So in this problem, very, very important, you need not only the first term, you also need the second term. Very important. And then here is your rule. It doesn't matter because we're adding 1 plus 1 or 1 plus 1. 1 plus 2 gives me 3, 2 plus 1. So I don't care how you guys write it, but you know you need to take 1 term before it. So if you want 2, which is the third term, you need to take first the term before it plus 2 terms right before it, and that will give you guys your answer. Again, if you wanted to, for this one, because you're adding, addition, cumulative, it doesn't matter, you can do a n minus 2 plus a n minus 1. It doesn't matter. And then once you do it, just check your formula to make sure, it works. I'm going to do one more. It's a little bit of an even more tricky one, and then we're done. It's just making you guys think a little bit. Okay. So let's take a peek at this one. So again, this one's hard. 1 plus 1, no. you know, you have to kind of keep playing around. Hopefully you guys realize. Watch this one. To get 4, if I take 1 plus 1, you get 2. What's 2 times 2? 4. That kind of works. Let's try this one. So to get this, 4 plus 1, 5. 5 times 2, 10. Okay, let's try one more. See if I can get this. 10 plus 4, 14 times 2, 28. So the pattern seems to be if I take, again, the 2 prior, do the sum, and then multiply it by 2. So one more time, I need the first term, and I need your second term. Again, these are hard questions. Here is the rule. We just discussed it. You want to take, again, I don't care which one you do. I'm going to do the opposite here so you guys realize it. 2 terms, or the 1 term. So I have to average or sum my, sum my 2 terms before. Again, you want to do n minus 1 plus n minus 2. That's fine with me. Times it by 2. And that is what we call the recursive special because there's no way for us to actually have written in explicit. So hopefully this makes sense. You won't have a lot of these. These are definitely tricky. These would be the advanced stuff for you. But you should be fine with understanding the difference between recursive and explicit, hopefully by now. So again, explicit, you can find any single term, 40th, 50th, 60th, you just sub it in the formula. Recursive is harder because you need an initial, and then you always need the term before it. All right, you guys, hopefully you understood the lesson. Now please try the homework, and I'll answer questions during our class time. Bye!